So without further ado, let's move on to the first slide. And we can see, and if you can remember, the rubber possible incident which happened recently, the rubber factory contaminated the water which causes deaths and violent repercussion. And then the salt water mixing with the Kaluganga introduces crop loss, and then the Kandy River eutrophication introduced fish deaths. So what happened was all these situations affected us, and what happened was we understood that such a pollution was happening after the hazard has been done, not before that. But what if we had the opportunity to understand it beforehand? So before introducing our solution, let me introduce the innovation and how are we unique. So in Sri Lanka, there are no product which can detect pollution beforehand. In a global level, we have only two. The first one is in USA, but it is in the size of a briefcase. It's very big, it's not portable. And the second one is in UK, which is just implemented for homes. So thereby, we introduce our solution, which is a portable, customized device to measure real-time toxic flow of waterways. And now, I will go to the demonstration. Here we have an IoT device which will be placing in waterways, such as water banks. Let's assume the Welikala river bank. And now, the probes, which is measuring the pH value, the turbidity, and the water temperature of water is introduced into the normal water of the Welikala lake. And now, Dinusha will introduce acidity by introducing vinegar to the water. And when the probes are being introduced to the water, now the pH level is 2.5. If you can focus on that. The pH value is 2.5 and the turbidity of water is 3.4 and the water temperature is now 20.8 and the temperature of the atmosphere is 25 in this room. So ladies and gentlemen, that is how our device tracks the water levels. And not only that, we will be connecting the data to the central server and thereby displaying this data in this graphical form. You all know the WQI standard. The WQI standard is the standard that we are using throughout this procedure. Here, the pH levels are being shown, and the lower margin is being shown in with a pH level of 7.1, and the higher ceiling is shown by pH level 7.4. And the points in between are the normal values, and the outliers are being shown here from the 0th position below and 0th position above. So likewise, we will be calculating and showing the values of pH, electrical conductivity of water, the chemical oxygen value, the total hardness value, and the turbidity value of water. These are the parameters that are considered when calculating the WQI standard. So this is the business model that we are introducing. We are mainly focusing the industries. For example, the apparel industry, because apparel industry spends around $20,000 to $7,000 in order to just detect these the harmful chemicals that they are emitting to the environment. And in households, in Sri Lanka, people are directly using water from rivers and wells, and in the northern province, it is quite a hazard because the water level is not quite okay for personal use. And then, for researchers, there are a lot of people like researchers and NGOs who are interested in doing this. So the device will be sold for 12,000 rupees, and then the device plus a 30 rupees a month subscription will be taken from the households, and the researchers will be given an API for their data, and with time we will be improving the quality of our data because we will be establishing this device in a lot of areas, a lot of locations. So the data value will be increased and we can establish data monetization. And here is a device that we are introducing for enterprises and for households. And as for the telco APIs that we are using CCaaS, LBS and SMS APIs, and the technologies are likewise. And in further implementation, we'll be introducing machine learning as well to predict the toxic flow of water. Thank you very much.